Greetings and welcome to the pod. My name is Mark West. Dr. Hannah Sassy is a virologist from the University of Sydney who studies the persistence of viruses in the environment. She's also an ocean swimmer who swims with Bondi Fit. Right now, many swimmers around the world are wondering whether it's okay to go for a swim during the coronavirus pandemic. Now, at the time of recording, a lot of the world is in lockdown or headed towards it, and a lot of beaches are closed. So some of this podcast is a moot point, and I wouldn't normally skip to the punchline of a podcast in the introduction, but for this I will. Right now, if you want to go for a swim, pretty much don't. In a public pool, don't go. In an ocean pool, don't go. If your lockdown laws allow you and your beach isn't closed, going for a swim at the beach is your best bet, but only if you take social distancing very seriously. Now, if your beach is closed, like a lot of Sydney beaches are at the moment, don't be a dick, don't go. Have a listen to what Hannah had to say about this. We started by going right back to the beginning. What is a virus?
Okay, so starting at the very beginning, a virus is an organism, and we call them obligate cellular parasites, intracellular parasites. So they can't replicate outside of a host cell. So whereas bacteria can grow in the environment. So if, E. coli is a huge waterborne bacteria, we use it as a water quality indicator. And so if there's bacteria in natural waterways, there has been a lot of research showing that these E. coli or same type of bacteria, we call them coliforms, and they're an indicator group that we use for water quality, drinking water quality, recreational water quality, surface water quality. And so they're associated with the human gut, so they're in turn associated with fecal contamination. So these bacteria can actually grow in the environment. And so you can have, a fecal contamination event with 10 bacteria, but by the end, you could end up with 10,000. So, because they can continue to grow. Whereas viruses can't grow without a host cell. So if you have 10 viruses somewhere, they're just going to stay there until they either are inactivated or enter a host.
Okay.
And so viruses aren't free living either. So there's a huge debate between microbiologists if viruses are actually an organism because they're not technically alive. But we get a lot of crap from other microbiologists.
So typically, if you, let's say you had a pool or an ocean and you left it alone for however long, and I guess we'll talk about how long they survive in the environment, but let's say we leave it alone for a week, there could be plenty of bacteria there, especially if there's fecal matter, sewage discharge or whatever, but viruses aren't living there typically.
Yeah, so that there could be if there was a sewage discharge, because there's a lot of viruses that survive wastewater treatment. And so that's, a whole other rabbit hole to go down is wastewater treatment. But so the viruses will just likely remain stable. So this is the perfect virus. This virus that we're talking about can, do it all. So in theory, the virus would remain stable and you would just have the same amount of virus. You would never have an increase, whereas bacteria, you could have an increase depending on the environmental conditions, if there's the nutrients present that it likes, if it's the right temperature, all of that. So the virus would just, you'd have the same amount of virus until it starts to inactivate or until someone comes into contact with it and it enters their body.
And so how long does it take a virus to inactivate if it's just floating around in water, say fresh water?
So that really depends on the virus. So there's two broader types of virus. There's an enveloped virus and a non-enveloped virus. So it's the exact opposite of what you would think. You would think an enveloped virus sounds more protected and it would survive longer, but actually enveloped viruses are much weaker. and non-enveloped viruses can persist much longer in the environment. And so that's just a structural thing, a structural feature. So a non-enveloped virus so say norovirus, which I'm sure most people have heard of. Norovirus is a non-enveloped virus, whereas influenza or even the coronavirus is an enveloped virus. So norovirus can persist in water for anywhere from hours to days, depending on the type of water and the temperature, the pH, if there's chlorine, all of that stuff. Whereas just based off of their structure themselves, an influenza virus likely wouldn't persist as long. So that is one positive of the coronavirus.
But it persists quite a long time I've read things that it can survive for 3 days on stainless steel and maybe even longer on glass. So it can hang around for quite some time.
Yes, it can. And so there's a lot of coronaviruses. So this COVID-19 is just one strain. And so coronaviruses people get regularly. They're just a common cold usually. This one is not, but other coronaviruses that you would experience, in your day-to-day. And so research has been done on those where they can survive up to 9 days on some surfaces. So I think right now the conservative advice is to assume that COVID-19 can survive up to 9 days, even though, the research that we've seen with COVID-19 specifically hasn't shown that. But a lot of people are just erring on the side of caution, I guess.
That makes a lot of sense. And so in a pool situation with chlorine, what does chlorine do to the virus? Would a typical public pool kill the virus or prevent a long existence?
Yeah, so it should, in theory. As long as the swimming pool has it's following a standard and has the designated amount of chlorine. So each, say we're talking about Victoria Park Pool. It's a publicly owned operated pool. That would be a really safe place to go water-wise because they have these standards where they have to take measurements of the chlorine and the pH every so often. And they have usually automatic detection systems with the pumps in the pool where it will read, the chlorine level has lowered either because there's been a huge people getting into the pool or, a dust storm or something has pushed a lot of organic matter into the pool. And so it will start to automatically inject more chlorine or ozone or bromine, whatever they're using to disinfect the pool. And so that should inactivate the virus within a minute. But the real problem in a swimming pool is when you're swimming with someone else and you're breathing hard and you're exhaling and you're creating droplets and aerosols. And if that somehow you come in contact with someone else's or they come in contact with yours, and that's where that transmission risk lies. It's not so much the water itself, but rather people in the water.
Okay, that's interesting. So I was sort of wondering if it'd have to be a really convoluted scenario, but yes, somebody could, everybody drinks water when they go, water goes in your mouth,
Yeah.
water goes all over you. So it seems unlikely then that the virus would get you that way. But if you swam past someone in a lane, you're both breathing or you're both at the end of the pool, that's the risk. So it's much like when you're just talking to somebody, you've got to stay 1.5 meters away from them, that sort of thing.
Yeah, exactly. And so, and one of the reasons is because so far there's not any evidence that the coronavirus is transmissible in water. And so, unfortunately, water research is kind of last priority when it comes to massive pandemics. But there is some going on, like they've found coronavirus in wastewater. So we know people are excreting it and it's going into the wastewater stream. And so, but there's still no evidence of the fecal oral route, which is most commonly associated with water transmission.
Okay. Um, and I guess if we're talking a public pool, there's the speaking to each other, that close proximity to people. But I guess the biggest danger with anything, I guess, is just common things that you touch, the change rooms, just being in common areas with other people.
Yeah, yeah, definitely. And I mean, again, breathing hard, you could breathe hard on something, and if you have it, you're excreting it in your saliva. If you spit or sneeze or cough or whatever, or even if you do it onto your hand and touch something. A lot of people, after you swim, you cough. You said you've swallowed a lot of water, and you don't know you're sick, and then cough, cover it with your mouth, and you say, oh, no, it's just because I swallowed a bunch of water, I'm fine. But there could be virus in that, and then you're going around to the change room, you're touching the door handle, you're touching the locker, if you have a locker, the shower head, the sink handle, the soap dispenser, all of that. And if you are shedding virus or you have it on your hands, you're spreading it all around. And vice versa, if it's on that, you could get it. And so I would say, change rooms at pools are not the greatest to begin with.
Yeah, that's
I'm
right.
sure
Yeah.
you know well.
Yeah.
So that would be a very hot point, I would say.
Can you transmit it through sweat?
It hasn't been shown that people are excreting it in sweat. And so it makes sense because that's a whole different system of your body, right? So you have your respiratory tract, and then you have your gastro, and then you have like your adrenal, and like all those glands that are creating hormones, and you're sweating and all of that. So it makes sense. They're different sections, if that makes sense, of the body. Yep. So there hasn't been any evidence that it's transmitted in sweat.
Okay.
Or even excreted.
And what about ocean pools? So they won't be necessarily, or even just the ocean itself. That's not chlorinated, but it is full of salt. It's full of other stuff, all sorts of stuff. What do you think about going to the beach or going to ocean pools right now?
That's a little trickier because viruses can persist in salt water, which we know from mostly gastroviruses. But again, those are much sturdier, much hardier viruses. I think the main draw with the ocean is that it's that like dilution is a solution theory. So if there's one person for every 2 meters and one of those people is sick and they cough it into the ocean, well, that's maybe 0.01 milliliters into how many, hundreds and thousands of liters in the ocean. So that is, one thing. And there hasn't been any evidence yet that, you can get it in the ocean, or that it will spread in the ocean, or that it will survive. And so again, that's just kind of one of the last things that people will probably look at. But it's not an ideal environment for the virus.
So if we're being really conservative, you'd say the beach might be okay as long as there's no one else around.
Yeah, definitely. And so there's still surfers in here at Maroubra, and it's really funny walking down the beach and seeing them because they're all spaced. Yeah. They're not clumped together. So I think a lot of people are taking mind of that. Ocean pools, I think, are a little different because it's a set amount of water. And if it's low tide, the pool's not going to be getting refilled. It's not going to be getting cycled out in fresh water. And people are much closer because there's only so much pool.
Yep. And breathing deeply.
Exactly. Yeah. And also there's going to be people who are just sitting there lounging, and there's going to be people who are swimming laps. And how many times have you had to swerve past someone floating around when you're swimming in the ocean pool? So it just creates a lot more contact potential and close contact potential.
Yeah, it's interesting. Like we could easily say, "Oh, well, don't touch anything," but of course, you touch the walls when you get into the pool. Like maybe you don't touch anything, but you still touch the walls when you get into the pool. You probably touch the railings, and if it's not chlorinated, it's not a disinfected environment. it could easily be
Exactly.
persisting. So maybe ocean pools are, yeah, even not touching anything, it's still probably not really okay.
Yeah, definitely. And so, I mean, one good thing about ocean pools is that it does have high sun exposure. And so that helps to inactivate viruses as well, with the UV from the sun. But other than that, I'd say ocean pools would be the riskiest of them, and then swimming pools, and then the ocean.
And then just the open ocean.
Yeah.
Every mammal on this planet instinctively develops a natural equilibrium with the surrounding environment. You humans do not. We move to an area.
So what exercise should we do? I went for a run the other day and I thought, this is great. There are actually a lot of people out because I think it's about the last thing you can do. And I had a drink at a bubbler, and then afterwards I thought, oh, I don't know about that. That might not have been the greatest idea, because it's a public thing. People would have touched it, made out of stainless steel.
Yeah.
What should we do?
Yeah. I mean, definitely keep running, and if you can, like, I would recommend, like, swimming, the length of the bay somewhere if you want to swim in the ocean. Like Maroubra, swim down the length of the bay. Coogee, same thing. Probably use a couple laps at Coogee though, because it's so small. But just as long as you're a safe distance away from people, it should be fine. So we've been doing yoga, like our yoga studios live streaming classes. You can do them in your home. Pilates, doing the same thing. Just going on little runs and staying away from people is the most important thing, I think, because people around here are still running and walking their dogs and surfing, but everyone's just keeping their distance, which is all you can really do. And then as far as you're saying, you went and got a drink, at the bubbler and touched it and all that, which is, you're obviously aware that you did that, so I'm sure you came home and washed your hands.
Yeah.
Yeah. So, you can't stop doing everything altogether. You would probably lose your mind. But just minimizing any sort of contact that you could potentially have with the virus in the environment and from other people.
So a little bit about you. Where do you like to swim?
So I have a long bus commute to get from Maroubra to the university. So what I like to do is just swim at Victoria Park first thing in the morning when I get there. It's because it's right behind my building. So I swim there. I swim at an ocean swim squad called Bondi Fit in North Bondi. And I didn't do that as much this summer as I did last summer, but I don't think we had as nice of a summer.
Yeah.
So it wasn't as enticing to go spend a Thursday evening in Bondi. But then obviously I live in Maroubra, and so we swim at Mahan, which is the ocean pool. And then I'm a little too scared to swim the bay because there was a great white last summer. So a really big one. So I can't get that out of my head.
I did the Maroubra swim a couple of years ago, and maybe this was the same thing you're thinking of. They delayed it for hours because a shark was spotted out the back.
Yeah.
Then yes, I still
I
did
just
it.
can't get it out of my head.
No, yes, it is a problem. How does a virologist, if I'm saying that correctly, work online?
So I am helping my students mostly. I have three PhD students that I help supervise. So I'm doing that. I'm writing papers were doing a quantitative microbial risk assessment for the transmission or the release of viruses from sediment into the waterway. And so mostly looking at that on how it could impact recreation exposures in freshwater, so like in swimming lakes and rivers, and irrigation water, so for fresh produce mostly.
Okay.
So yeah, just changing things up and looking desktop instead of lab bench. But you know, it might be nice to do this for a little while, and then I'll be aching to get back into the lab. So
Yeah, well, yeah, finish off the papers, publish or perish. I guess now's the time.
yeah, and it's grant writing season too, so I guess I could try and do that.
Yeah. And, this question will come out all wrong, so I'm sure I will edit it. But in the virus world, this is obviously a really bad occurrence. This the COVID-19 version of coronavirus. What other dangers are there? I guess if this had a higher fatality rate, it would be even worse. Is there anything worse to come?
I mean, I think, so if you think about it, it's been about 100 years since we had the Spanish influenza, and then about 100 years since the Black Plague. And so it seems like it's cyclical with stuff. And so one big driver for the coronavirus explosion, so we not just COVID-19, but we also had SARS and MERS, and those are all coronaviruses, is this One Health theory, which is basically, you know, the health of humans depends on the health of animals, which depends on the health of the environment. So everything is interconnected. And so this COVID-19 and SARS were thought to come from bats. And I think MERS too. And so with this outbreak specifically, it was, you know, wild bats coming into a city, into an animal and fish market. And so normally humans aren't going to have close contact with bats. You know, you see them, they fly over you, but you would never be up close with a bat. Bats aren't going to be in contact with other mammals, usually. You know, they're basically the only flying mammal. So this is all unnatural. It's not a normal occurrence. And so this has happened before too with Nipah virus, which was an outbreak, you know, maybe at the start of the 2000s-ish. But that was thought to come from pigs. And the pigs were being pushed further and further into the jungly, like very heavily treed area because, you know, human expansion on villages and towns and cities. And so these pigs were coming into contact, domesticated pigs were coming into contact with wild bats. And it was thought that that was how it transmitted. And then humans, of course, slaughtering and the husbandry of raising pigs. So all of these new exposures, it could be anything, you know, we could have even completely unrecognized viruses. You know, at least we know this was a coronavirus, and we were able to establish that pretty early on. Coronaviruses are quite distinct, which I'm sure by now everyone has seen a picture of what a coronavirus looks like.
Yep.
So they're quite distinct. When Ebola emerged, you know, scientists had no idea what it was, no clue. It was one of the first filamentous viruses that had been found, certainly one of the worst. So as long as humans are, you know, pushing into wild habitats and wild animals, and there's always this possibility. And especially now with how easy it is to get from one end of the world to the other, and how often people do it and how many people do it, it's, you know, it could lead to a pandemic much more easily.
Yeah, I mean, that makes sense. You know, these things evolved in their own little evolutionary niches, and then another one pushes into it. I mean, viruses it doesn't help, not that they're alive, but it doesn't help them to kill us, because then they can't be transmitted. So,
yeah,
you take one niche and merge it with another one, and bad stuff's going to happen,
Exactly.
it kind of makes sense.
Yeah, and so, like you said, viruses, they don't want to kill us to start because they need us. So they'll just push us to, excrete more virus, more virus. So that's why when you have a gastro virus, you have diarrhea and you're vomiting, because the reaction of your body is to get rid of the virus, but the virus is replicating and replicating. And so then symptoms are releasing the virus. So,
how interesting is that? I guess that's kind of obvious when you think of it like that, but I hadn't really thought of it like that. I mean, that's so interesting.
Yeah. And I mean, same, like if you're asymptomatic, that's another thing. So the virus is still in you and it's still replicating and you're still excreting it, but you're not showing any symptoms, which means that you could potentially pass it to other people much more efficiently because you don't know you're sick yourself. Rather than someone who knows they're sick, they're feeling awful, they'd stay home, they'd stay in bed away from others. So that's one of the COVID problems that we're having, is a lot of people are asymptomatic. And so they're spreading the virus. They have no idea.
Yeah, it's a horrible mixture of everything, isn't it? So why does it actually need a living body? What does it get out of a living body that it can't get out of the environment?
So the virus replication cycle is a little complicated, and of course it's different for every organism. So it doesn't have a metabolism. It can't take in nutrients and create anything basically from a nutrient, like a bacteria or a parasite or, you and I.
Is that the biggest reason why we don't call it alive? Like it's not a life form?
Yeah. So that's one reason. It also I would say that's the main reason why most people don't consider it to be its own life form. But it also sometimes will hijack, your own, or like whatever host cell, it will hijack the mRNA and stuff that's used to build a new set of DNA or RNA, a new genome basically. So sometimes most of the time viruses can't do that on their own. So they go into the cell and hijack whatever machinery they need, cellular machinery, of course, they need to synthesize a new genome. And so, because viruses are very small, and so the less they have, the better it is for them. As a metaphor, it's much easier for you to carry a backpack than to carry everything you own, if you're going to your friend's house or something. So it's same for living organisms. They keep it as an as-needed basis. And so bacteria will get rid of, proteins or genes that they're not using. Some can. And so if they're living in the lab for however long, they'll likely get rid of some proteins that they needed in the environment, but they don't need anymore.
Okay.
So viruses basically keep it simple, I guess, in an easy way to say it, but they don't have a metabolism and they don't have everything they need to, uncoat their genome and create a new one.
Right. Okay. So yeah, they get into the animal and then use the animal's mechanisms to reproduce. So kind of hijack the factory. Yeah. That's interesting.
Yeah, exactly.
Can plants have viruses?
Yes, yeah. So there is a virus for just about every living thing. Plants, bacteria have their own viruses called bacteriophage.
Wow.
And so also, animals, humans, everything, fungi have viruses, cyanobacteria, so algae has viruses. They're everywhere. I think there's only one organism, it's like maybe a yeast, doesn't have a discovered virus yet.
Right. Oh, that's interesting.
Yeah, they're the most abundant organisms by far.
Okay, that's so interesting. And so a computer virus is actually a pretty good analog, really.
Yes.
Simple little bits of code that then uses the computer's machinery to spread itself around.
Yep, exactly. Yeah. I mean, I think mostly what's just important with any viral disease, if you get it or if someone has it, is just staying away. And also, it's very important that people know that antibiotics are not.
Yes.
That is a huge thing. It's just like a common misconception. People. It's not people's fault. They think, oh, I was sick last time and I got antibiotics, so I need antibiotics this time. But yeah, in the COVID-19, I mean, I think it's just really important to take it seriously. And as we've seen, it's not just a cold, or it's not just a short-term thing. It's sticking around, and just keeping your distance and maintaining proper hand hygiene is just really important right now. I mean, we know that so far it can't be introduced in water or food, so because it hasn't been any cases where people have gotten it from food or water. But we do also know that some patients present first with diarrhea, and then a few days later they'll have respiratory symptoms. So that leaves the possibility open. If you're swimming with someone and they just had diarrhea and they might have COVID, so then they could actually be releasing it into the water.
Of course, yeah.
Yeah, so just to take, the distancing really seriously is really important right now.
I actually remembered one question I wanted to ask you. My parents, their neighbour claims that his doctor said he was immune to COVID-19 because he has been on malaria treatment for some time. And I've heard this around the place, that malaria drugs might help, but it sounds like, there's something promising there, but also it sounds like we've got some spread of fake news as well.
Yeah, I think that is probably a bit more of a fake news thing.
Yeah.
So there's been some test treatments with hydroxychloroquine, which is, I think quinine is the malaria treatment, like the active in that. So I think they're somehow in that same group of treatment, but it hasn't really been shown that it actually works. There's been some treatments. There was a published paper with a case cohort of 6, maybe, so not a lot of people in this study that were given some treatments, and, the results are still unclear, but I wouldn't say anyone's immune to coronavirus unless they had already had this strain of coronavirus. And because we still don't know how your body responds to it. So we don't know what type of immune response is created in your body or how long it lasts. SARS and MERS lasted only about a year. So if this continues to go on, people who've already had it could potentially get it again if their antibodies have lowered.
Right, so it's more that the antibodies will have lowered after time as opposed to the virus mutating itself?
Yeah, so I don't think there's been any evidence yet of this virus mutating, and so I think a lot of people were worried about that. Like influenza, it can reshuffle its genome and, do all kinds of crazy stuff. It's such an interesting virus, but there hasn't been any evidence yet that coronavirus can do that.
Okay,
so
that's one plus.
Yeah.
Although it's probably not out of the question, I guess, because it's quite. I know that the time scales with virology can be different, but it's still early days, isn't it?
Yeah, it definitely is. The virus is sequenced really quickly, which is good, but then we need to work out, how can we make more of it so we can study it in the lab and all of that. So I think that's just being done now. And, we have the qPCR for the diagnostic, which is good, but we still don't have a serology diagnostic, which is how you test an antibody response. So that's going to take a lot of time. And then, we're still at least a year and a half away from a potential vaccine being released. So it is early days, definitely.
Wow. Well, hopefully that doesn't mean a year of lockdown, but I mean
Yeah.
it's not out of the realms of possibility, is it?
No. So we actually got an email from some research done at University of Sydney in the engineering department where they did some modeling, and they were saying that basically 80% of the entire Australian population needs to practice social distancing, like the 2 meters apart, staying home, all of that. And in order to reduce the spread, it would still take 3 months. So if 80% of the population is adhering, it would take 3 months. And then they also said if 90% adopted it, then it could potentially be controlled by July. But as it stands now, we're nowhere near that.
Yeah, I actually saw that paper, and I saw the write up in the ABC, and there's some turning point between 70 and 80%, wasn't there? Because 70% we weren't getting
Yeah.
better. At
Yeah.
80% there was at least a horizon.
Yeah. So hopefully that will be taken seriously. And it'll suck, but it'll be better than,
It's better than having
more
it.
people dying, getting sick, this being just, a lasting, lingering thing.
Yeah, yeah. Thank you very much to Dr. Hannah Sassy for taking the time to take us through the risks of swimming at the moment during the coronavirus pandemic. If you'd like any more information on what she had to say, get over to the website at www.thepodpodcast.com. That's www.thepodpodcast.com. Please feel free to get in touch. I'll be at home. I'm homeschooling 2 kids, trying to hold down a full-time job. But where else am I going? Everybody stay safe, practice appropriate social distancing, adhere to your local lockdown rules, and I'll catch you next time on the pod.